So hi, I'm Pratik again, and now we'll talk about affine transformations on independent variables and their effects on the plots of different functions. So here we consider t to be a real variable, a comma b are reals, and so the affine transformation we define as t goes from t to at plus b, and so when the variable goes from t to at plus b, we study the changes which the plot of the function xt undergoes. Here in the future slides, I will show you different plots of xt and x of at plus b in various stages, and in all the plots ahead we consider that a is greater than 1 and b is greater than 0. So this is the function I choose, x of t. So now we move to x of minus t. So as you can see, the plot has just flipped around the y-axis. I'll just show you the previous plot again for reference. So this is how x of minus t looks like. Here we have multiplied the independent variable which is t by minus 1 and plotted the function. Next we go to x of at. A, as I reminded you earlier, is greater than 1. As you can see, the plot has compressed here, and I can see that Ashwit here has a confused face. He might want to say something.
Normally when we multiply with something that's greater than 1, we expect it to get bigger. Why is the graph getting smaller?
Yeah, I understand that this might confuse a lot of students. So we now take the example of an exponential which Ashwit talked about in a previous video. Consider e power 2t. So we draw e power 2, the plot of e power 2t here, and this is the function e power 2t. Consider when t is equal to 2, the value of the function, which is the function is x of t, so the x of 2 will be equal to e power 4. So we plot t equal to 2 here, this is the t axis. So e power 4 lies somewhere here. So note that e power 2, which is e square, will lie here, and e square is the value of the function, say x dash of 2, and x dash of t will be equal to e power t. We plot e power t again on the same graph. So this is the plot of e power t. We'll label this e power t. Now as you can see, the graph of e power t has compressed when you go from t to 2t, and that's how you explain the apparently counterintuitive paradox which Ashwit noted, and I hope that answers Ashwit's question this time. So now we move on to x of t by a. Again, a is greater than 1, and as expected, the graph of the function has expanded and not compressed as was in the previous case. Now we move on to shifts, which is x of t plus b. Remember that t is positive here. As you can see, the graph of the function has shifted to the negative real axis. Remember that t is positive. This might cause some confusion among the students. Ashwit here has something more to say on this. I hope what he says makes you understand it a bit more.
So intuitively this looks like you're looking into the future, and the signal in the future would look like something, but we are in the past and we're trying to bring that signal back to the past.
Yes.
So intuitively the signal will be shifted towards the negative axis. So that's why it looks like this.
Yes, that's a very intuitive explanation. So let's do this a bit more mathematically this time around. So consider the plot of the function x of t, the original function we saw. So that function looked something like this. So this is the t axis, this is x of t. So now we have changed from t to t plus b, b is positive. So consider a specific value of t, say t is equal to 0. So when t is equal to 0, t plus b actually lies somewhere here. So when we plot it on the t plus b axis, which is this plot, the previous plot, this t plus b value actually gets mapped to the value of 0, and similarly every value on the t plus b axis gets mapped to a value b units to the left of it. Therefore every value on the t plus b axis gets shifted to the left by b units, and hence the plot on the whole also shifts to the left as is shown in the diagram. So this is how you explain a linear shift in the independent variable. This is similarly a graph of t minus b. Here, as expected, the entire graph shifted to the right instead of to the left. So now we combine both the transformations we have studied so far, multiplication of the independent variable and a linear shift. So this is the graph for x of at plus b. As you can see, the effect of a can be seen in the compression observed in the graph. The effect of b can be seen as the graph has shifted to the left and not to the right. But if you notice carefully, the shift in this case is not as much as the shift you observed in just the plot of x of t plus b. I will show that graph again. So this is x of t plus b, and this is graph of x of a t plus b. The shift here is noticeably less. So how we explain that, we show in the next slide. So again we observe that in the previous plot the shift is smaller than the one in the plot for x of t plus b. So we explain that by writing x of a t plus b as x of a into t plus b by a. So a is non-zero and a is greater than 1. So as a is greater than 1, b by a will be smaller than b, and the shift observed will be b by a and not b. As a result, the shift observed in this graph is lesser as compared to the shift observed in the previous graph. So this is the graph for x of a t minus b. Again the shift is smaller and it is to the right and not to the left.
So Pratik, do we apply scaling first or shift first?
Yes, I would like, so before answering that question I would like to show you another graph. So this is the graph of x of minus a t plus b. As you can see here, b is positive, as I remind you again, b is positive. However, the graph has shifted to the right and not to the left. So here I come to the question Ashwit asked. The operation you apply first, shift or scaling, is important, and if you don't take care of that, you won't be able to analyze situations like this. So I would like you students to discuss this on the discussion forums, and I will be ready to help whenever you have questions. So we move on to a last graph, which is again an extension of the same graph. So here we just show x of minus a t minus b. Again, as in the previous graph, the shift is not as expected, and this again can be explained by the order of the operations. Thank you.